All right, let's look at the linear substitution. Let's say we have a differential equation, dy over dx is equal to capital F of this linear expression, ax plus by equals c, right? If that's the case, we can use a substitution technique. So we're going to let this guy, so this linear expression, going to let this guy equal to v. Right? Then, so we're going to let, let's see, we're going to have, let v is equal to ax plus by plus c, right? Then if you take the derivative with respect to x, so you're going to have dv over dx is equal to, right, derivative of ax with respect to x is a, and derivative of by with respect to x would be b dy over dx, and derivative of constant c would be 0, right? Then you can see that since we can call this a whole entire expression inside v, we can call this guy f of v, right? So this is equivalent to dy over dx. So what we can do is take this guy and plug it in here, right? Then we have this new equation, dv over dx is equal to, right? So you have a plus b times, right, this is going to be just a function of v, right? So as you can see, the right hand side is written all in terms of v, no other variables. So this is going to be a separable equation. So this is the separable equation. Right, so we can use the technique we learned about the separable equation to solve this differential equation. Right, so let's look at an example. All right, so we have a differential equation, dy over dx equal to quantity x plus y plus 3 squared. All right, so we have this linear expression here. What we're going to do is we're going to do a substitution. So we're going to let v be x plus y plus 3, right? So we know that this guy right here is going to be v. So the expression we get is just a v squared, right? So as usual, I'm going to take the derivative with respect to x. So we have a dv over dx is equal to derivative of x is 1, and derivative of y would be dy over dx, right? And the derivative of 3 is 0, so it goes away, right? But since we have expression for dy over dx, which is v squared, so we can plug this guy in right here, right? So what we get is going to be simply 1 plus v squared, right? So we have this separable equation. So we're gonna put all the v's on one side and all the x's on the other side. So I'm going to, let's see, I'm gonna have to put this expression on the other side. So I'm going to divide through by quantity 1 plus v squared, right? So you would get 1 over 1 plus v squared, right? We have a dv over dx, which is was already there, and this is equal to, right? So you divide 1 over v squared by itself, you're going to get 1 left over, right? Then the next step is I'm going to do it in the same line. I'm going to actually integrate this guy with respect to x, both sides. So we put the integral sign here with respect to x, and I'm going to put the integral sign here and with respect to x there. All right, then we can of course cancel out the dx here, dx there. All right, and luckily we actually can find the antiderivative of 1 over 1 plus v squared with respect to v. That's arctangent, right? So you have an arctangent of v is equal to, right? Antiderivative of 1 with respect to x would be just a x. And then we probably have plus some constant c. So we have that. All right. So since we are looking for we're looking for y, so first we're going to find the v. So I'm going to take the tangent of both sides. Then you will get v is equal to tangent of x plus c. All right. Then v is x plus y plus 3. So this is going to be x plus y plus 3. Right? Then we already know that this is equal to tangent of x plus c. Right? So in order to isolate y, we can simply subtract x and subtract 3. Right? That way we will have y is equal to tangent of x plus c minus x minus 3. Right? So that is the solution of the given differential equation. All right? That's it. I hope that this was clear.